Today, I'm going to show you how to create a trading bot from scratch in Python. This bot can be used on stocks, forex, and crypto. For this, we need Python, a code editor, and a broker with good API access. To install Python, just head over to python.org, go into Downloads, and download the latest version. Once that's finished, run the installer and make sure that you click the box that says Add to Path. Next, you will need an editor, and I like to use VS Code, but you can use anything that you're comfortable with. Now I need to select a broker that has good API access. I'm going to use OANDA for this, but I'm not affiliated with them, so use whichever broker you're comfortable with. I've created a demo account for the purpose of this video. For my trading bot to be able to connect to this account, there are a couple of things that I need to take. The first is the account ID, which is this number here. So I make sure to copy that and take a note of it somewhere. And the second thing is my API access key. So I head over to Trading Tools up here and select the OANDA API. That takes me over to the API page where I can generate my own personal token. When I click this button, it will generate a token for me. Now that I've got everything that I need, I can start working on my trading bot. The first thing I'm going to do is create a file called config.py, and I'm going to paste that information that I just took from my account. I create a variable called OANDA API key, and that's where I paste that API token that I just got. And then I have another one for my OANDA account ID. This way I can always have that information stored and I can access it whenever I need from the trading bot. In the same folder, I will create my trading bot. For this, I've used the Jupyter notebook, but you could also just use a regular Python file. But the notebook makes it a little bit easier to present, so that's why I've used it for this video. Inside my trading bot, I now need to import the config file so that I have access to the information inside of it. And I can test this out by printing out the OANDA API key. When I run the code, I can now see that key coming up here. So it's pulling through from the config file. Typically, when working with APIs, you have to manually handle all of the connections. But fortunately, OANDA has created their own API wrapper. This simplifies the whole process a lot and makes it much easier to communicate with the API. This isn't something that's standard in Python, so I need to make sure that I install it. I hit the Windows key and type cmd to bring up the command prompt. There I type pip install OANDA py v20. I already have it installed, but normally this will just take a couple of minutes to download and install. Now I can start using that library, and first of all I will import API from it. This will allow me to create a connection to my account directly. So I'll get rid of this test line of code and I will paste in this line instead. What this does is calls that API class and it passes in my access token, which we're getting from the config file. This will create a client connection. I will print that out just to check that it works correctly. And if I run everything again, I now have a connection to my account. And there's a lot that I can now do with this connection. So if I head over to the documentation for this OANDA library, I can see the various endpoints that I can use. The first thing I want to do is download some price data. So for that, I'm going to use the instruments endpoint. It's got various options here, but I'm interested in candlestick data. And this actually makes it quite easy because it tells me what I need to do and gives me some sample code. The main thing I need to do is use this instruments endpoint. So I head back over to my code, and at the very top, I'm going to import that instruments endpoint. Then back in the documentation, it says that the next thing I do is create my client connection. Well, I've done that. And then I define my parameters, the params. It gives an example of what should go in there up here. So count is the number of candles that I want, and granularity is the time frame. So that will give me my parameters variable, and this function call underneath is what actually calls for the data. So in there, I pass in the instrument that I want data for, and the parameters that I just defined. So let's use this to download some price data. So I've defined my client. I'll get rid of this line here and create a new code block underneath. Here, I'm going to define my time frame and the instrument. You can use whatever you like here, but I'm going to go with 15-minute candles on pound-yen cross. So I'm going to use this on Forex to begin with. I then define my parameters. So here I have granularity, which is my time frame, and that's the 15-minute time frame. And then an optional variable, which is the type of price that I want. Here I'm specifically looking for ask prices. You can request ask or bid, or even mid prices, but I want ask specifically. After that, I can use that instruments endpoint that I just imported. In there, I pass in the instrument, which is pound yen, and I pass in those parameters that I just defined. And then I can send that API request to OANDA. This will send the request to the client and put the response into this variable called data. So let me run everything now. And at the end, output data to see what it looks like. So if I scroll down, I've now received pound-yen data on the 50-minute time frame, along with a whole bunch of individual candles. So for each candle, I have additional information here. I don't actually need the instrument or the granularity because I already know those. I passed them in the first place. I just need the candle data. And because this is a dictionary, I can just add candles at the end so that it's only going to get this information. And I will rename my variable from data into candles. So if I run this again, I now just get the candle data. It's a little bit unusable in this format though, so I'm going to parse this data and put it inside of a data frame that I can work with a little bit easier. I'm first going to iterate through this candles list with a for loop, and then I will check for an important condition. You notice that the first key here is complete, and that says if it's true or false. What that's referring to is whether the very last candle that it received has completed or if it's still live. I'm recording this at the weekend, which means that the market is closed and that candle is completed. But during trading hours, the last candle is going to be going up and down, which means that this variable here is going to be false. When working with this price data to calculate my indicators and entry and exit points, I need to use only the completed data. Otherwise, my indicators could repaint. So I'm only interested in candles where the complete variable is true. As I iterate through this list, I can extract data for each candle, but I need somewhere to store them. So I'm going to create an empty list. This will be a temporary list, but it will allow me to store this information as I extract it. The information that I'm going to take is the time of the candle, as well as this open, high, low, and close prices. You could also take volume, but I don't use that in my trading bot, so I'm not going to. So after I've checked if the candle is complete, I'm going to extract that information from the candle data. And that's what this block of code here does. It gets all of the individual pieces of information from this candles data, and then it stores it inside of my data list. Once I have my list, I can convert it to a pandas data frame. But before I do that, I have to actually make sure that I've imported pandas. So right at the top, I'm going to import pandas as PD. And I'll just rerun this single block of code to make sure that I'm able to import everything. If you get an error here that says that one of these modules can't be found, then you simply bring up the command prompt again and use pip install and then the name of the library. Now I can head back into this block of code, and once I have my list, I will create a data frame from that data list called df. And I can print this out and run this whole block of code just to see what I get. So now my candle data is presented in a much clearer format. I have the open, high, low, and close prices. I have the time for each of those candles, and I've received 500 rows of data. I can request more or less. This is OANDA's default value. The last thing to do is to make sure that this time column is actually in date time. So I'll add this one line of code here, which will convert it to make sure. If I rerun it, you should now see that this time changes to a better format. Now that we've got this data, let's visualize it and see how it compares to the actual price chart. And if I compare it side by side with the price chart from OANDA, it's essentially the same data. So now that I'm confident that this works, I can get rid of this plotting. That was just to visualize it. And I can go back into this section that retrieves the data. The trading bot is regularly going to need to fetch this price data. So I want to wrap this inside of a function. What I will do is right at the top, add a line that says define get_candles and pass an argument for the time frame. I can then indent all of this inside of that function. And instead of printing the data frame, I will return the data frame. I need to make sure that these two variables here match up. So I change my time frame into TF. Now what I can do to get price data is go down here, create a new code block, and I can actually just call that function. So if I run everything again, this now calls the function and stores it inside a variable called price. So I get the exact same data, but it's much easier to now access it. Now I have a trading bot that's able to connect to my broker and quickly fetch price data. The next thing I want to do is to define a strategy to generate trade signals. I'm going to keep it simple with an EMA crossover strategy, which means that I need to calculate some indicators. I could do this manually, but instead I'm going to use an existing library that can calculate indicators for me. So right at the top, I'm going to import pandas_ta as TA. And again, if you get an error with this, then just make sure that you use pip install pandas_ta. So right underneath this function for getting the candles, I'm going to create a new function. And this one is going to be called calculate indicators. It will take the data frame as an argument and then calculate indicators on it. First, I need my EMAs. For my strategy, I'm going to use the 5 and 8 period EMAs. So I create new columns inside my data frame. One will be called EMA underscore 5 and the other is underscore 8. And then I use the pandas TA library that I just imported to calculate the EMA on the close prices with the two lengths that I specified. This is super flexible and I can change these to whatever EMA cross that I want to use. The EMAs will give me my entry signal, but for my stop loss, I plan to use an ATR, the average true range. So I calculate that as another variable inside of my data frame. I'll create a column called ATR14 because it's going to use the 14 period for its length. And that's actually all that I need. So once those calculations are done, I need to return that data frame back from the function. So let's head back down into this section of code that was downloading price data. It was getting the candles from OANDA. What I can now do is take that price and pass it straight back into my calculate indicators function. So I pass the price back into it, it will get the indicators and it will give me the updated data frame. I will run everything again and the code executed fine. So now I should be able to output that price. And this time I see the same data frame as before, but now notice there's 3 extra columns which contain the indicator values that I wanted. Now I've got my data and I've got my indicators. So the next thing is to define the strategy logic. This will go inside of another function called EMA crossover. And just as before, this function also takes the price data as a data frame. There are a few things that I need to define for my strategy. The first one being the take profit ratio, which I'm going to set as 1.5 to 1. So whatever my stop loss is going to be, the take profit would always be 1.5 times that size. Now I need to define the logic for the EMA crossover. So if I have a look at my data, these are the 2 columns that I'm going to be using. So how does an EMA crossover work? Well, I've got the 2 EMA lines here. The blue one is the 5 period and the red is the 8 period. The crossover happened somewhere around here. The way I'm going to code the logic is that on one candle, the 5 is going to be below the 8, but on the next candle, the 5 is above the 8. If that happens, then that means that it's crossed. The 5 period went from being below to above the 8 period. Since I'm checking for it in real time, I need to use the 2 most recent available candles. So I get the very last one and I check if the 5 EMA is above the 8 EMA. And then I get the one before it and I check if the 5 EMA was below the 8 EMA. If that condition is true, then the crossover has happened on the last candle. That means that I need to fetch both of those candles from my data frame, which is what I do with this section of code. So I get the last candle as -1 and the previous candle to that as -2. These index values allow me to work backwards from the end of a data frame. So if you use a negative value, it starts at the end and works backwards. -1 is the very last value, and then it goes -2, -3, and so on. And after that, I can implement the logic for checking for the crossover. I look at the last candle and see whether the 5 was above the 8, and then I look at the candle before that to see if 5 was below the 8. If these conditions are true, then I have a crossover. For now, I don't have any trade logic, so I'm just going to output buy signal is generated. But if that condition is not met, then I add an else statement, which just says strategy conditions not met. Unlike my other functions, this function doesn't need to return anything because it processes the logic inside of it. So I'm going to tidy up my code a little bit here and remove this section and move it somewhere else. So I have my functions in order. I have my first one for getting the candles, then I have one for calculating indicators, and then the actual strategy logic. So I can piece them all together by just pasting in that code that I copied from above. I get the candles, calculate indicators, and then lastly, I call the EMA crossover function and I pass in the price. So I'm going to run everything now. And my output is that there is a buy signal. The 5 period EMA crossed above the 8 period. And I can check that by printing out the price data once more. So if I scroll all the way to the bottom where I see my last 2 candles, on the second to last candle, the 5 period EMA is very, very slightly below the 8 period. But the candle after, it's very slightly above. So that gives a confirmation of a crossover and generates a trade signal. Now what I can do is combine all of this functionality into a central place for the trading bot. I'll add a function called runBot, and I'll add a print statement to say starting trading bot. Now I can take this block of code from here and put it inside the trading bot logic. So now all of that stuff is handled inside this one function. And with the function created, I can then call it underneath. So let me run everything again. And now I get the same output as before, but now it's all contained inside this one function. So this combines all of the building blocks of the trading bot in one place. So now the bot is running kind of independently, but the trade signals that are generated, all they're doing is printing out a print statement. So what I want to do next is actually place orders. Back on the documentation for OANDA's API, there is an endpoint for orders. And when I go in there, there's various different classes that I can pull from it. The one that I want for now is order create. This gives me an example of what should go into an order. The important part is in this line of code here. This is where I actually pass the order through the API, and I need to pass the order data along with it. So I'm going to create a new function that's going to handle the order creation for me. Just underneath this calculate indicators function, I will add a new code cell and start this function. The arguments that I will pass are the stop loss and take profit levels. Now I can start defining the actual order data. I need to specify that it's an order, and then I pass in some of the details like the instrument name, which is already stored inside this instrument variable, the number of units, which I'll just keep as 1 for now, the order type, which could be a limit or stop order, but I'm going to use a market order for this to keep it simple, and then the stop loss and take profit positions. This is where I use the stop loss and take profit variables inside of these two data points. You'll notice that at the end, I have this funny little bit of code. What this does is formats it to have 3 decimal points. The reason for that is because the instrument I'm trading is pound yen, and that uses 3 decimal points. So if I was to specify a stop loss that's say 194, and I try to do more than 3 decimal points, it won't let me. Which means that when I pass this data to the API, I need to make sure it matches the format of the instrument. Otherwise, this is going to come back with an error. I can now make the API call, but first I need to import that endpoint. So right at the top here, I'm going to import the orders endpoint. Back inside my place order function, I can now create that order by calling order create, passing in my account ID, and then passing in that data from above, this order data up here. And then I submit that to the API. And to give some kind of visual feedback that this has been done, I'll do a print statement to say placed order for this instrument, and then the details of the stop loss and the take profit. Now that the function is made, let's test this out before I actually add it into the bot. So I'm going to comment out this section. I don't want to actually run the bot yet. I'm just going to place an order, and I'll pass in a stop loss of 194 and a take profit of 195. So let's run all of the code again. And this time it comes back saying placed order for pound yen with a stop loss of 194, take profit of 195. I can actually see that order. So I've got my market order here. So it just immediately filled. Take profit is up here at 195, and my stop loss is down here at 194. Now I need to link this inside of my EMA crossover function so that it's the function itself that places the orders. The orders are placed when the conditions are all met, which happens in this if statement. So I need to work out a few pieces of information before I can place an order. So in here, I can call that place order function. However, it needs a stop loss and a take profit. And before I can calculate those, I need to know where my entry point actually is. Because this is a market order, I'm going to be buying at the last price, and that came from my last candle. So if I just take the last candle's close price, I can set that as my entry price. From this entry price, I can now define my stop loss, which is going to be ATR based. Within my indicators function up here, I calculated the 14-period ATR, average true range. So I will use that as my stop loss size. Underneath my entry price, I will calculate the stop loss, which will just be my entry minus the ATR. I then want to calculate my take profit, which is 1.5 times the size of the stop loss. I know where my entry price is, and I know where my stop loss is. So if I subtract the two from each other, I can work out the size of the stop. Finally, using all of this information, I can work out where my take profit should be. It will be at the entry price plus the stop distance multiplied by the take profit ratio. Now I have the variables that I need, the stop loss and take profit, that go into this place order function. So I can go back down here and get rid of this manual place order and run my bot all over again. So the trading bot ran through, but the problem is the strategy conditions weren't met. If I have a look at the 5 and 8 period EMA, there is no crossover. So of course, there is not going to be an order triggered. But on the 5-minute time frame, there has just been a crossover. So I can cheat and just change my time frame for 15 minutes to 5 minutes, run all my code again, and this time it detected the crossover, sent a buy signal, and confirmed that an order has been placed. And back over on my chart, I can see that order with the take profit and the stop loss correctly placed. So this is all working now. However, the bot only runs through once. I need the bot to be constantly running and always checking for new candles, new trade signals, and placing new trades. That means that this run bot function needs to be placed inside of a loop. Once the bot starts, it will then immediately go into a while loop, and then everything else is going to be contained inside that while loop. But of course, I can't just send constant queries to the API. Realistically, I only need to check for new prices when a candle has closed. So in my system, I'm trading on the 15-minute time frame. So that means that I need to check every 15 minutes. Inside of my loop, I'm going to check the current time. Notice that this introduces a couple of additional libraries. So I go back up to the top and I make sure that I import date time and time zone. And while I'm here, I'm also going to import time because I'm going to use that as well. The next thing after getting the current time is I need to check the timestamp. So I check if this is a new 15-minute candle. And I do that by extracting the minute from the current time, dividing it by 15 using this modulo divider, which gives me the remainder. So if the remainder is 0, then that means that I'm either at 0, 15, 30, or 45 minutes past the hour. In addition to that, I only want to be checking within the first 10 seconds of that minute. Any longer than that, and the price might have moved away from what I need to be entering. However, this also means that I can check multiple times within that first 10 seconds. So I don't want to do that. I only want to check once. And once I've done that, I can say, okay, I've checked this 15 minutes. So I'm going to wait another 15 minutes. So I need to add a little flag at the top here, which is going to be last checked, and I'll start it off as none. I then use that variable directly inside of this if statement. So what this says is if the last check time is different to the current time, then we can proceed. But if it's the same as the current time, then that means that I've already done the check in this interval. So I'm going to skip this and wait for the next 15 minutes to pass. But if this condition is false, then that means that this is a new 15-minute candle. So I'm going to say checking for trade signals. I can then get the price data, calculate the indicators, and check my trading strategy. So all of this code now moves up inside of this if statement. Once this is finished, I need to make sure that I record the fact that I have just checked this 15-minute candle. So I set the last check variable to the minute of the current time. That means that all of this code isn't going to run again for another 15 minutes. And lastly, just to give a little bit of breathing room to this while loop, I'm going to make it sleep for 1 second each time it runs, so that it's not firing constantly, but it takes a little break in between checking the time. So now I can rerun my code, and it's going to say starting trading bot, and now you see it's actually continuing to run. So what it's doing now is checking the current time, and it's waiting for a 15-minute interval. That isn't very useful for testing purposes, so I'm going to temporarily change my time frame to 1 minute so that I can get responses much quicker. So I change it up there. I also need to change it down here. So I'm going to comment this line out and add a new line. And instead of dividing by 15, I'm just going to divide by 1. And what I will also do to get some feedback is add the current time inside of this if statement. So if I run everything again, it's going to say start in trading bot, and now it's going to wait for 1 minute to pass. So I let the bot run for a couple of minutes there, and you can see that it checked the time at 10:49, then again at 10:50, and actually at 10:50 there was a trade signal and it placed another order on the pound yen. And now you have a fully automated trading bot that can fetch data, it can calculate indicators, and it can place orders. There's plenty more features that can still be added, but this gives a solid foundation to start from.